In this problem, let's take a look at finding the derivative of y with respect to x, even if y is not given explicitly as a function of x. We're given that the square root of x cubed plus y squared is equal to the cotangent of y, but we are not given the value of y as a value of x. And in this case, it's actually impossible pretty much to solve for y in terms of x. Nevertheless, we can find the derivative by differentiating implicitly. So let me recopy down the starting point, y cubed plus y squared is equal to the cotangent of y. And then we differentiate with respect to x. When we do this, on the left-hand side, the derivative of square root will be 1/2 of the inside x cubed plus y squared to the negative 1/2 times the derivative of the inside. The derivative of x cubed with respect to x is 3x squared. The derivative of something squared with respect to x is going to be 2 times the something times the derivative with respect to x, so dy dx. And here, there's no dx here because the derivative of x with respect to x is just 1. And so it's not necessary to have a second term on the 3x squared. However, it is necessary to have a second term over here because I'm not differentiating with respect to y, but with respect to x. On the right-hand side, the derivative of the cotangent of something is the negative cosecant squared of the something times the derivative with respect to x. And the derivative of y with respect to x will be dy dx. Okay, so just a reminder, again, this part here, the 3x squared, did not require an extra term because the derivative of x with respect to x is just simply equal to 1. Here, the derivative of y with respect to x is the derivative of y with respect to x. Same over here. And so it was necessary to have these extra terms on these two parts, but not on this part. All right, now the next part is basically algebra. Solve for dy dx. And so this now becomes a complicated algebra problem where I need to isolate the dy dx. Okay, so on the left-hand side, we multiply out. We get 3x squared over 2 times or square root of 3x squared plus y squared. The second term with 2 over 2 would cancel. And now I get y over the square root of x cubed plus y squared times dy dx. That is equal to negative cosecant squared of y times dy dx. Okay, and so there are two terms that have a dy dx. There's one term that does not. So I'm going to bring the term on the right over to the left-hand side, this term on the left over to the right-hand side. And I get y over the square root of x cubed plus y squared times dy dx plus cosecant squared y dy dx is equal to negative 3x squared over 2 times the square root of x cubed plus y squared. Okay, now there's two options from this point. Let me do the most straightforward approach, and that is factor out the dy dx. So I factor out dy dx, and I get y over the square root of x cubed plus y squared plus cosecant squared y. That is equal to negative 3x squared over 2 times the square root of x cubed plus y squared. And so I can just simply divide now, and I get that dy dx is equal to negative 3x squared over 2 over square root of x cubed plus y squared divided by y over the square root of x cubed plus y squared plus cosecant squared of y. Okay, now that is a huge, huge mess. To simplify this mess, let me get a common denominator on the denominator. So I have negative 3x squared over 2 times the square root of x cubed plus y squared. So the numerator does not change. In the bottom, I would have y plus cosecant squared y times the square root of x cubed plus y squared all over the square root of x cubed plus y squared. Okay, so now I have two fractions that are being divided. And so I will multiply by the reciprocal. I have negative 3x squared over 2 times the square root of x cubed plus y squared times, I now multiply by the reciprocal, square root of 3x squared plus y squared all over y plus cosecant squared y times the square root of x cubed plus y squared. And so my last simplification will be to cancel out the square roots. So I would have negative 3x squared all over 2 times y plus cosecant squared y times the square root of x cubed plus y squared. And that's the answer, and it doesn't get much better than this. I could, so that's the answer, and I'll just box that as the answer. I could have saved myself a little bit of work on this step here. So suppose that on this step here I factored out dy dx and then isolated. So let me just do an alternate solution. Suppose that I started from this point and then I clear out the denominator first. So let me multiply by this denominator on both sides. So let me mark this in purple to mark where I'm going to do something that's different. On the left-hand side, I would have 2 times the cube root, square root of x squared cubed plus y squared times the right-hand side, y over square root of x cubed plus y squared times dy dx plus cosecant squared y dy dx equals negative 3x squared over 2. So what I did was I multiplied, actually not over 2, minus 3x squared, pardon me. I'm going to take this denominator and just multiply it up on the left-hand side. Okay, so when I do that, then these, if I then expand, these cancel. So I would have 2y times dy dx plus 2 cosecant squared y times the square root of x cubed plus y squared times dy dx equals negative 3x squared. I then factor out the dy dx as before. And I get 2y plus 2 cosecant squared y times the square root of 3x squared plus y squared. That's equal to negative 3x squared. And then if I divide down by the thing in the brackets, I get that dy dx is equal to negative 3x squared over 2y plus 2 cosecant squared y times the cube root of, the square root of x cubed plus y squared. And that matches what I had over here in black, except for the fact that I didn't factor a 2 out. Okay, so all this to say, it might be helpful to clear out denominators first before solving for dy dx. That might be an algebraic tip to make things go a little bit easier. It's certainly not necessary. We can work with this messy fraction in black and simplify it to get the correct answer. If you prefer the approach in purple, by all means, feel free to do that when approaching a problem like this.